Welcome to the GrowClass series, Part 1, Introduction to Growing. Today we'll be covering a variety of information covering the basics of setting up your grow room, making the decision about your type of growing style, and just some basic general information to get you started. So let's go ahead and dive right in and talk about what we're going to be discussing today. So first and foremost, we're going to be going over the basic environmental factors you should have in your grow room for optimal results. Following that, we'll be covering lighting, the basics of what these light fixtures consist of, as well as the different advantages and disadvantages of each style. From there, we'll be covering the different growing styles, we'll go over the nutrient system basics, and then briefly cover pH and EC and ppm. So thanks so much for joining us. Go ahead, sit down, sit back, relax, enjoy, and let's go ahead and get started. Well, now that we've covered what we're going to be going over in this whole class today, let's dive into our first topic, the basic environmental factors of a grow room. It's important that we keep the environmental factors of the space we're growing in within certain ranges in order to get optimal results for the plants we're growing. We're going to cover a couple of different factors, so let's go through what we'll be talking about. First and foremost, we'll be covering the temperature of the grow room. From there, we'll be discussing the actual relative humidity of the grow room, as well as the ventilation and CO2 concentrations and their importance. So let's go ahead and dive right in, first and foremost, to temperature. As most people are going to be familiar, the temperature is going to simply be how hot or cold the environment in which you're growing your plants is. Different plants are going to have different preferred temperature ranges. However, for our purposes, we're primarily going to want to stick between 70 to 78 degrees. This range will vary slightly based on the variety of other environmental factors that we're going to discuss and can be calculated on a more advanced level with a calculation called vapor pressure deficit, or VPD. We'll cover that in more detail in a further video, but for now, let's just focus on the basics of the environmental factors. So now that we've gone over the temperature, let's discuss the relative humidity, or the concentration of moisture in the air in the space. It's how humid the room feels. That's the best way we can quantify what the relative humidity is. For the purposes of what we're doing, we're going to stick between about 45 to 55% relative humidity generally, with this varying if you're going based on the VPD calculation. By keeping those relative humidity temperatures in optimal ranges, we reduce the risk of mold while giving the plants the proper amount of moisture in the air to grow at the fastest peak rate they can. Another important factor is going to be ventilation. So depending on how you have your grow room set up, you're typically going to either have an intake and an exhaust system or an HVAC system, which is actually going to cool and heat the air. Depending on what kind of system you have, things will vary slightly. However, generally speaking, the rule of thumb is that we want enough air exchange in the air in the space roughly every 3 minutes. If you're doing this with an intake and exhaust system, it'll be a little bit different than doing it with an HVAC system, as the HVAC system is going to have plenty of circulation going through the condenser that operates the unit. With an intake and exhaust system, you will need to make sure that you put those intake and exhaust fans on proper timers in order to get proper circulation in that grow room. And last but not least, let's discuss CO2. CO2 concentrations have a massive impact on the actual function of the plant, how fast it can grow, and primarily the yields you're going to get from it. CO2 has been directly linked with scientific studies to a 10 to 30% yield increase, and particularly with the plants that we're growing. So let's talk about what concentrations we should be striving for. Before we dive in that though, let's note something very important, which is that there is always a passive concentration of CO2 in the air around us. And what our purpose is here is we want to actually elevate that concentration to a level that's going to make the plants move at a faster metabolic rate. Plants consume CO2 and produce oxygen, unlike human beings, which produce CO2 after we consume oxygen. So for our purposes, we're going to want to talk about the concentration that you want to see in veg versus flower. In the veg space, it's typically going to be peak efficiency to have your CO2 concentrations between 300 to 800 parts per million. For the bloom, it's going to vary a little bit, with it typically being anywhere between about 1,000 to about 1,500 ppms of concentration of CO2 in the space. Typically, you do not see CO2 supplementation in vegetative spaces nearly as often as you do in bloom spaces. The reason being is the largest benefit you're going to see from a CO2 concentration will be demonstrated in the bloom room. While in the vegetative portion of the plant's life, it does absolutely expedite the growth and the metabolic function within the plant. However, it's not going to be as easy to quantify because you're not going to have bigger buds like you would in flower. So now that we've covered these environmental factors, just keep in mind that there's always going to be a level of variance, and it's about keeping the room in an acceptable range that's actually doable for you. In a perfect world, we keep these environmental factors within these ranges that I've noted, but unfortunately, sometimes we have to be realistic about the limitations of our grow room and make sure that we're trying to keep them as close as possible in order to get the best possible function out of the plant that's reasonable with the tools we have at our disposal. So excellent. That's the environmental factors. Let's go ahead and dive right on in to our next topic. Excellent. Well, now that we've covered the basic environmental factors of a grow room, let's dive into our next topic, lighting styles. Lighting is critical when growing plants of any kind, and particularly when you're doing it indoors, as we're supplementing and substituting what would typically be the sun's impact on the plants. Because of this, there's a variety of different lighting styles that are going to have different advantages and disadvantages and applications depending on the type of grow room you're setting up. Let's go ahead and cover the different types of styles we'll be going over, as well as the basics of a lighting fixture. So let's talk about the different styles. We're going to be covering a couple, but it's by no means all of them. They're primarily going to be the most popular ones. So first and foremost, we're going to be covering high intensity discharge or HID lighting. From there, metal halide or CMH lighting, as well as light emitting diodes or LED lighting, and last but not least, we'll be covering briefly fluorescent lighting as well. When it comes to a lighting fixture, most of them are going to be composed of three primary components: the ballast, the bulb or diode, and the reflector. Each plays an important role in the lighting fixture as a whole and plays a different role in actually getting those lighting fixtures to operate properly. So let's start with the ballast. The ballast is going to be the unit that actually connects to the wall and converts the energy that's coming out of your socket into a form that can ignite these high intensity discharge lights, ceramic metal halide, LED, or fluorescent lighting. The different type of ballast will depend on the electricity you have available to you, depending on whether you have 120 volt, 240, 277, 347, or all the way up to 480 volt. However, in most home grows, you're going to be operating between 120 volts and 240 volts based on what electrical service you have available in the building you're using. It's important to make sure you select the proper ballast that matches up to the actual voltage of electricity you have available, as a 120 volt ballast will not operate on a 240 volt outlet. So, let's go on from there. The next important part of a light fixture is going to be the bulb or diode. With most of the fixtures we're going to be discussing, with the exception of LED, they're going to be operating off of bulbs of some kind. This is actually going to be what's ignited, and it's usually a gas-filled tube of some kind that emits a different spectrum of light depending on the gas inside of it, the way it's ignited, and a variety of other factors. LEDs are a bit of an exception because rather than using bulbs, they use diodes. So there is no gas ignition. It's going to be actually on the fixture, and it operates similarly in the fact that when powered it produces light within a certain spectrum. However, they do not degrade in the same way, or they do not have the same kind of issues that sometimes you can run into with bulbs where the gases degrade over time, the ignition can slow down, and sometimes the bulbs will just burn out. While this is possible with diodes, it tends to take a longer time because there's not a lot of components that can degrade quickly. From there, let's talk about the last but probably the most important portion of the lighting fixture, which is the actual reflector itself. So by using the ballast in the bulb, we're creating plenty of light. It's not an issue there. However, it's important that we're directing that light into the correct areas in order to get the optimal effect out of it and actually see the plants benefit from the light that we're generating. The reflector plays that role. It's typically going to be some kind of aluminum reflective material. Sometimes it'll be different materials, but aluminum tends to be the most popular, that will allow the light to bounce from above the bulb back down to the fixture so that we're not spreading light in all directions. So, now that we've covered the basics of these lighting fixtures, let's go ahead and dive right into our next portion of this, the actual specifics of each of these lighting styles. Let's get into a little bit more specifics, and first and foremost, let's talk about high intensity discharge or HID lighting. HID lighting is typically what's thought of as traditional grow lights. This is because it's been around for the longest, and it's typically one of the most. HID lighting has two subcategories that are important, which is going to be the single-ended HID and the double-ended HID. The biggest difference between these two fixtures is going to be the actual bulb and how it connects to them, but there's some more significant impacts between them that is important to understand. So let's cover the single-ended first and foremost. Single-ended HID fixtures are going to essentially be a large version of the bulbs that you use in your house. It operates on the ballast, reflector, and bulb operation like we discussed previously, and it's going to be a single point of connection with a large base that screws into a socket, typical to something you'd see in your home, but at a larger scale. These fixtures are available in a variety of voltages as well as a variety of wattages, determining the actual output of the light. It varies from anywhere between 250 to 400 to 600 to 1,000 watts with a single-ended HID fixture typically. These fixtures have great light penetration, and because of the actual output of them and the intensity they produce, they do have enough concentration that you need to make sure they are suspended far enough away from the plants that you're not actually going to bleach the chlorophyll within the plant tissue from over-intensity of light. Typically, when it comes to a single-ended HID as well as a double-ended HID, at the bare minimum, we want to have 3 feet from the bottom of the fixture to the top of the plant. This is important because A, it helps make sure that the light's being spread adequately and we're not over-focusing light on a small area, and B, helps with actual heat distribution because these fixtures do produce a significant amount of heat, and by having them too close to the plants, that can cause heat stress on the plant. And last but not least, the actual intensity off those fixtures, if they're brought too close to the plant, will act kind of like a magnifying glass, where it will bleach the chlorophyll in the plant, which will prevent the plant from further photosynthetic processes, which means that it's going to slow down the actual growth of the plant. So, single-ended HIDs are a fantastic option. However, in more recent years, the new development has come out, which is the double-ended HID fixture. The double-ended HID fixture is going to be a little different because of the way that the bulb actually operates in the fixture, as well as it being a tiny bit more efficient overall. Double-ended HID fixtures, rather than using a bulb that has a socket that screws in, double-ended HID fixtures have a two-point connection, which are going to be two wires that slide into the fixture and lock in. Because of these 2 points of connection and the fact that the electricity can run through the entirety of the bulb rather than having to run to the top and back like it does in a single-ended fixture, you tend to see that double-ended HID fixtures operate anywhere between 10 to 15% more efficiently than their single-ended counterparts. The biggest thing with a double-ended HID as well is that it has a greater output, generally speaking, as these units are available in 600 watt, but more typically 1000 watt. The reason I say 1000 watt is most of these fixtures are going to be actually at full blast operate anywhere between 1150 watts to 1200 watts. It's important to recognize this when doing your electrical calculations and accounting for the draw, as the 200 watt difference over several fixtures adds up very quickly. The biggest thing with double-ended HID fixtures is that they are made to be at a greater suspension height away from the plant. Excellent. Well, now that we've gone over HID lighting, let's move on to our next lighting style, ceramic metal halide, or CMH. Ceramic metal halides are an excellent middle ground option between HID and LED lightings that are a little bit more energy efficient than your traditional HID, but have a deeper penetration than your traditional LED fixture does. Because of this, they're a fantastic option for indoor grow rooms or any space that has limited ceiling or HVAC capabilities. The ceramic metal halides are available in a variety of different options as far as the wattages go, and then do have some different options regarding the bulbs as well. As far as the wattages of these fixtures go, they're available in three options at this point in time: the 315 watt, the 630 watt, or now the 1000 watt option. With the 315 and the 630 watt, it's going to use a unique bulb that is for specifically the ceramic metal halide. It has a different point of connection, and it's actually going to operate a little bit differently than your traditional bulb does. They have a little bit longer of a life, and overall have a much better broad spectrum than any of the HID options that are currently available. Because of this, ceramic metal halide options are not only very popular for indoor grow rooms with limited HVAC or ceiling height, but they're also very popular to be used as a spectrum enhancer in a room that already has HID lighting by checkerboarding them in the room. By doing this, you take advantage of the ceramic metal halide bulb's expansive light spectrum that includes a good combination of red, orange, yellow, blue, purple, and UV light, covering the massive majority of the light spectrum that's available to plants. On top of that, ceramic metal halides have a deeper penetration into the canopy than you would find with your traditional LED, which we'll cover more in just a moment here. On top of that, the biggest advantage that makes them similar to LEDs is that lower energy consumption, which directly correlates to a lower heat output, as the amount of electricity pulled from a lighting fixture is directly correlated to the amount of heat being generated. So if you're looking for an option for your grow room that's going to allow you to have a lower ceiling with lower suspension above the plants and a better overall spectrum, ceramic metal halides could be a fantastic option for your grow room. Now on to LEDs or light emitting diode fixtures. LED fixtures have become wildly popular over the last few years as the technology has gotten more affordable and better. LED lighting is a little bit different than all the lighting we've discussed up to this point, because while it does still use a ballast and in some form of a reflector, it does have diodes instead of bulbs. The biggest difference here is that diodes are going to be electrical components instead of a gas-filled bulb, which means these diodes can actually be manufactured to a much more specific spectrum with less degradation bulb in your HID or ceramic metal halide setup. Because of this, LEDs have a fantastic spectrum and it can be dialed into exactly what you're looking for. So if you're looking for specifically far red light to help with genetic activation, or you're looking for really far blue and UV spectrum to actually increase the resin production in the plant, LEDs are a fantastic option. Because of their lower energy consumption, they have a lower heat output similar to the ceramic metal halides. One thing to keep in mind with an LED, however, is that the light penetration off of these fixtures is drastically reduced from a ceramic metal halide or an HID fixture, which means we have to operate these a little differently than we would these other fixtures. With a ceramic metal halide or HID fixture, it's about keeping a minimum distance from the tops of the plants to the bottom of the light. With LEDs, it's flipped a little bit. LEDs typically need to be anywhere between 12 to 36 inches away from the plant, however it's typically 12 to 24. And this is in order for the light to actually be able to penetrate any depth into the canopy, so you're not just getting good top nugs. Because LEDs have that very specific spectrum, and because they don't have quite as much light penetration, but it's much more concentrated, what you do tend to find out of LED lighting is a much more resinous and dense product than you would find out of using other lighting styles. LEDs have many great applications, but more and more we're seeing them used in vertical growing or again, spaces with limited ceiling height and limited HVAC capabilities. On top of that, the LED fixtures, the components of them are not going to degrade as quickly, and the chances are that you'll have to replace any portion of the LED fixture is going to be significantly reduced. Part of that to understand is that a quality LED fixture, however, is going to be exponentially more expensive than a quality HID or even ceramic metal halide, as many of these components are going to be much more expensive to be put together, and the technology is quite simply newer and being developed still. So when you're trying to select a lighting option, if you're thinking that you want a very specific spectrum and you're worried about having to replace components over the long term, LEDs are going to be a fantastic option. Last but not least when it comes to lighting styles, let's talk about fluorescent or T5 lighting. Fluorescent or T5 lighting is an incredibly energy efficient, low output, low heat output lighting option that's fantastically popular for propagation and vegetative growth. It does not have a deep light penetration similar to an LED, and so the fixtures have to be relatively close to the plants that are being grown underneath of them. Because of this is why they're very popular for propagation, cloning, seed starting, and even vegetative growth for smaller plants. These lights can be suspended directly over the plant within 6 to 12 inches oftentimes, as the light penetration does not go very far and the heat being put off the light has very little risk of burning the plants. Fluorescent lighting is very popular for a few reasons. A, it's very energy efficient, allowing it to be daisy chained, so multiple fixtures can be connected together and powered off of a single outlet, which makes it a great option if you have limited outlets in the space you're growing in and need to cover a broader area of space for vegetative or propagative purposes. On top of that, fluorescent lighting is really inexpensive relative to many of the other options that we've discussed in this video. Fluorescent lighting is available in a variety of options, varying from the 2-foot to the 4-foot long bulb length, and fixtures that vary from 1 bulb all the way up to 16, sometimes even 32 bulbs in a single fixture. The bulbs are easy to replace, inexpensive, and they can be selected in a variety of different spectrums based on what your application you're trying to use. However, they're typically going to be very high in the blue portion of the light spectrum, as that's what's used for vegetative growth. Fluorescent lighting is not going to be a fantastic application for the bloom portion of a plant's life cycle, as it does not have the penetration or the output in order to actually generate a significant yield out of the plants you're growing. What you will find is typically plants that are flowered under T5 lights, similar to LEDs, have a very high resin content and are relatively dense at the top of the plant, because that's where all the light is being focused. So if you're looking for an inexpensive, low energy, low heat option for your grow room, particularly for vegetative or propagative purposes, fluorescent lighting is going to be a fantastic option that'll be easy to use and low maintenance. Now that we've gone over the basics of lighting fixtures, as well as the different basic lighting styles, let's go ahead and dive into one last thing relating to lighting, which is the actual lighting spectrum. Lighting spectrum refers to the different colors of light that are being put off by your plant, and will impact the growth style that you get out of the plant. The light spectrum varies in different colors, however it typically goes from your UV, blue, purple, green, yellow, red, and orange on the lighting spectrum. These portions of the light spectrum are all very important, and it's important to understand the impacts that each portion have. One thing we'd like to get up off the front is that the green portion of the light spectrum is not visible to plants, which is traditionally why when you see people operating in grow rooms where the lights are off, you'll notice that there are green lights in the room. That's because true green light is unseeable to plants. They actually cannot consume it. It's basically their colorblind portion of the spectrum. So when it comes to the blue, purple, and UV, that's going to be typically for the vegetative portion of the plant's life cycle. And when we're referring to this for bulbs, this is either going to be the metal halide or MH portion, or typically is going to be somewhere in the 42,000 Kelvin or higher range, which is just a rating for lighting spectrum. When we're discussing red, yellow, and orange light, which is going to lean itself towards the actual flowering or blooming portion of a plant's life cycle, this has a lot to do with the elongation of the plant, as well as stimulating certain hormones inside plants that tell the plant, hey, it's time to flower. So, when trying to select which bulb you're going to use, keep in mind that there's definitely going to be benefits to using a blue, purple, or UV light and metal halide light in the vegetative portion of the plant's life cycle, as it will cause more leafy green production and tighter internodal stacking, opposed to the red, yellow, and orange, which is fantastic for the bloom portion because it causes elongation in the plant, allowing the plant more space to fill in and cause greater yields, bigger nugs, which is what most of us are shooting for. When it comes to LEDs, it's going to be a little different, however, because LEDs do not use bulbs, they use diodes. Diodes are going to be designed into certain portions of the light spectrum when you get the fixture. Traditionally, with most LEDs on the market now, what you're seeing is them moving to what's called a full spectrum portion of the light, which utilizes all different portions of the light from blue all the way to red. These don't have incredible hot spots typically in particular portions of the lighting spectrum like you would see with an HPS or metal halide bulb. However, their broad coverage of the spectrum gives you a great overall result and a little bit of the best of both worlds. Nowadays, what you all will say with your HID is ceramic metal halide lighting is that it's very popular to actually mix these bulbs in a checkerboard pattern in order to simulate a full spectrum layout like you would see with an LED. This is oftentimes a little bit more effective than your full spectrum portion of for an LED, as a mixed combination is still going to have the hot spots in red, blue, and purple, and UV that's going to stimulate things like increased genetic activation with your red light, or going to increase resin production or internodal stacking with your blue, purple, and UV light. Just make sure you understand that which bulbs are which application, but it is also important to understand that if you really get down to it, you're not going to get into a situation where the plant's life cycle is going to ruin the plant. It simply will change the structure of the way the plant grows, and the same applies to HPS. So when selecting a bulb, just go with what you think is going to be best for you. Or if you have any questions, always make sure to ask, as there's definitely plenty of different people that are available to help you in making that selection. Now that we've covered the basics of the environmental conditions of a grow room, as well as the basics of lighting for our grow room, let's go ahead and dive into the next portion of our video, the different growing styles that can be used. There's a variety of different growing styles that are available to us, and each of them have their advantages and disadvantages. The most important part when selecting a growing style is understanding their application and making sure it's going to be a system you feel comfortable maintaining and using to grow your plants. So, two primary categories we'll be discussing today: your soil or soilless systems, and then your hydroponic systems. So let's go ahead first and foremost and discuss the variety of different hydroponic systems that are available to us to grow these plants. First and foremost, there's flood and drain. Flood and drain is a very simple, easy to apply hydroponic system that uses a small number of components but is easily automated to allow you to feed a variety number of plants all in one feed cycle without having to do the individual labor. Flood and drain systems take advantage of a flood tray as well as a reservoir for the nutrient solution, and then the plants are put into the flood tray in whatever pot you choose to use. However, fabric pots tend to be very popular. And from that point, what will happen is periodically throughout the day, the pump will be activated, flooding the tray with nutrient solution, allowing the plants to suck that nutrient solution up, feeding themselves. This is great because it's easy to automate, easy to apply, and easy to maintain. But one thing to keep in mind with a flood and drain system is that if you don't have your flood and drain system dialed in properly, you can oversaturate your plants, reducing the number of feeds that you can get within a day or in a week, which is overall going to reduce the efficiency of growth in your system. So with the flood and drain system, it's about understanding the correct amount of water for the correct amount of time to be pumped into the system, which unfortunately is usually going to be best found by playing with the system a little bit and judging how the plants are drying out, as each type of pot is going to operate differently in these systems. On to our next type of hydroponic growing, which is incredibly popular, which is going to be drip irrigation. Drip irrigation is similar to the flood and drain system in that it's typically going to take place in a flood tray. However, rather than the nutrient solution being pumped directly into the tray and the plant sucking it up from there, the nutrient solution is pumped into an irrigation line that goes to a series of drippers that are put directly in the plants. As that water is pushed up with the pump, as the timer is activated, it will irrigate the plants slowly over time. One of the biggest advantages of a drip irrigation system is the amount of precision and control you have in how you're irrigating your plants, which oftentimes is going to allow you a much more aggressive feed cycle, as you can control exactly how much water the plants are getting, allowing them to dry out more quickly, allowing you to re-irrigate them more quickly. Drip systems can be applied to a variety of different mediums, and it's not strictly going to be a hydroponic system. However, it is incredibly popular for things like rock wool, hydroton, or even coconut coir. This can also be applied to soil as well, but it's just important to understand the medium you're working with and how it dries out in order to properly dial in your drip system, similar to a flood and drain. It'll take some time to understand the way and the rate at which your plants are consuming the nutrient solution and how long each of your feed cycles should be. Oftentimes there's two approaches when it comes to drip irrigation. There's going to be high volume, low frequency, meaning you're going to pump a large volume of water for less times a day, or low volume, high frequency, so very small concentrations of water many times throughout the day. This is often going to come down to preference. However, the low volume, high frequency system does tend to lend itself to a little bit faster growth as there's more rapid oxygen and nutrient solution exchange occurring with the plants. On to our next system, deep water culture or DWC. Deep water culture or DWC is another hydroponic system that's going to be available to you, and it's very easy to apply. However, there's some important things to understand about using it, as there are some hiccups that you can run into. A DWC system consists of a bucket with a nutrient solution and then typically a net pot or mesh pot with a growing media in order to hold the plants up. In this application, the growing media is actually not really for the roots to grow through as much as it's for the plant to offer support so that you're not constantly having it leaning over. As the plant grows, it'll grow down through that net pot directly into the roots, into the nutrient solution, allowing for the plant to be fed all the time. DWC systems do lend themselves towards incredibly aggressive growth for this reason. However, because the roots are directly exposed to the nutrient solution at all points in time, it's incredibly important that we maintain that nutrient solution more so than some of these other systems, as a small variance in that can cause a much more drastic result in a small window of time. DWC systems typically will have the nutrient solution being agitated with either a pump or an air pump, increasing the oxygen in the solution, which is better for the plants overall. From there, there's going to be the cousin of the DWC system, the recirculating DWC system. A recirculating DWC system is going to be identical in application to the DWC system except for one different component here. Rather than being an individualized bucket with an individualized nutrient solution, our DWC system is going to be a series of DWC buckets that are connected together with a centralized reservoir so that it can be maintained more easily. When it comes to changing out the water, if you have a large variety of simple DWC plants, what you'll find is you're having to change each individual bucket, which increases the labor going into each of this, and is just going to reduce the time you have to spend working on the plants themselves, which is what most people are more concerned about. And our DWC system takes some of the hassle out of this by centralizing the water solution into a central reservoir that's pumped through a series of tubes that go between all the plants in the solution. Our DWC systems do have some of the same concerns as the DWC, as you do need to make sure that you maintain the nutrient solution incredibly efficiently, as small variances can have a massive impact over a small window of time. These are really popular options if you need to have a very rapid pace of growth, and also are going to be available to be on site with your plants most of the time. So, those are the basics of hydroponic systems, and obviously there's a lot more detail that goes into these systems, which we can get into in a later video, but we wanted to give you a basic understanding. So let's move into the next portion of this, your soil or soilless portion of the grow. So, as most people are familiar with, when it comes to a soil grow, it's going to be what most people think of farming or growing anything in any application. We're going to have a soil medium that we plant the plants in, and which is going to have a nutritional composition that's usually built right into it from whatever dry amendments were built into the soil to actually build it. And periodically what we'll do is apply water to that, which will break down any existing nutrient composition and feed the plant. And as that is broken down over time, we'll have to supplement with liquid fertilizers in order to ensure that we're getting the proper nutritional content the plant needs in order to get optimal growth. Soil systems are fantastic simply because it offers a buffer against any mistakes, unlike most hydroponic systems. While hydroponic systems do have an incredibly fast rate of growth, they also have an incredibly fast rate of things going wrong, as the nutrient solution is being directly exposed to the plants all the time typically, causing them to have a much greater impact and not allowing there to be any kind of buffer to prevent any issues from occurring. In a soil-based system, that soil acts as a buffer, so it will actually modify the pH based on the pH of the soil and the water, and actually prevents some drastic impacts from occurring up front. For this reason, soil systems tend to be incredibly popular with new growers, as it offers you a little bit of peace of mind that you don't get when it comes to a hydroponic system, as well as offering a little bit less labor intensive, as soil tends to hold water over a period of days. So when it comes to a soil system, you're typically going to water once every 2 to 3 days, as opposed to a hydroponic system in which you're going to be applying typically anywhere between 1 to 8 applications of irrigation per day. The same is going to apply to soilless mediums as well. A soilless medium is going to be very similar to a soil, it's just going to be composed of different components. Most soilless mediums are going to be composed of either sphagnum peat moss or coconut coir. And while they operate similar to a traditional soil, there are a couple of things to understand depending on which medium you're using, particularly when it comes to coconut coir. Coconut coir is going to be shredded coconut husks and is an incredibly popular option when it comes to propagation, as it is inexpensive, very sustainable, and it does allow for pretty aggressive feeding, as it's a middle ground between hydroponics and a soilless system, as it can be used in either application. Coconut coir, however, does have a unique relationship with calcium and magnesium, causing it to need a little bit different of a nutritional composition than other growing mediums typically do. Because coconut coir latches on to calcium and magnesium in a different way than other mediums do, you'll find that you'll need to supplement additional calcium and magnesium in any kind of coconut coir-based grow than you would your traditional hydroponic or soil grows, or even your sphagnum peat moss soilless. So, those are going to be the basics of growing styles. As you can probably understand, there's a lot more detail that can go into these. However, each of these is going to have levels of intricacy that you'll learn as you play with them. And it's all about trying different styles and understanding which is best for you. So, think about the way you want to grow, how much time you have to spend with your plants, and make a decision from there. And just keep in mind that many of these systems can be adapted to use a combination of each other, making it for a nice middle ground where, for example, you can use a drip irrigation system on a coconut coir, which will reduce your labor for irrigation, but the coconut coir still acts as a buffer so that if your irrigation system were to fail, you're not going to have dead plants because you didn't get water one day. So think about the different options and understand that each option works fantastically. It's just about applying them in the correct method. So we've gone through the environmental conditions, the basics of lighting, and now the different growing styles that are available for you to use in your grow room. So let's move on to the next portion of this, the actual nutritional systems we'll be using with these plants. It's important to understand that in order to get optimal growth and yields out of the plants we're growing, we have to provide adequate nutritional content to them, which is going to be typically composed in a liquid nutrient formula, but also is available in dry nutrient formulas as well. So there's a couple of things that are important to understand in the understanding a nutrient system, and so let's dive in first and foremost to how they're broken down. Nutrient systems are going to be broken down into two categories. There's going to be your base nutrients and your additives. Base nutrients refers to the basic nutritional content that's needed to get your plant from point A to point B. It's simply going to be the nutritional content needed to keep the plant alive and growing. Not necessarily get the optimal results out of the plant, but give it what it needs in order to continue its life cycle. From there is where we get into what we call the additives. Additives are going to be specialty nutrient formulations that have very applied applications. So whether it's a bloom booster, a root mass expander, a mycorrhizal inoculant, or something like that, each of these products is going to have a unique impact on the plant, unlike a base nutrient fertilizer, which has a general application of feeding the plants. So now that we've gone over the basics of nutrient systems, let's go over a couple more important elements of nutrient systems as well as a few tips. So an important thing to understand about any nutrient is the actual application guidelines that are provided. If you go and pull a bottle off of the shelf and look at the bottle, typically what you're going to find on the side is what we refer to as the general use application of that fertilizer. It's going to be how the manufacturer suggests using it if you're using it by itself or you're not using it in a greater nutrient formulation. However, almost all nutrient formulas, whether organic or synthetic, are going to have an actual feeding chart application for these nutrient fertilizers, which is going to be more specific to when you should apply this fertilizer depending on which portion of the plant's life cycle you're in. General use applications are going to tell you how to use it, whether the plant's in the beginning of its bloom cycle, the end of its bloom cycle, the beginning of its veg cycle, or the end of its veg cycle. It's not specific instructions. So when it comes to applying our nutrients, we almost always are going to want to go based on the manufacturer-provided feeding chart, at least while we get started, as this is going to be more specific to the portion of the plant's life cycle that we're using these nutrients in. Almost all nutrient companies are going to provide these online through their websites, or we can find them for you. From there, let's go into a few tips that I like to cover when feeding nutrients. Oftentimes people think that it's simply a matter of mixing the nutrients in water and calling it a day and that there's no place for errors. However, this is simply not true. When you're mixing nutrients together, you're playing amateur chemist, and it's important to understand there are factors involved in that in order to make sure you get the best possible results that we want to observe. First and foremost, when feeding nutrients, it's important that we always start with fresh, clean water. We never want to use water that's already got nutrient solution in it, as we're not going to have an immense amount of control over the total solution at the end. From there, it's important that we always make sure that we apply these nutrients one at a time directly to the water. You should never take two nutrient formulations and mix them together directly. They should always be mixed in solution of water. That nice, clean, fresh water, and it's important that you follow the application of those on the feeding chart as well, as some nutrient formulations need to be added to the water before others in order to get the best possible results and allow them to interact properly in the solution. The other thing that I like to recommend to people is just a note for ensuring that you don't run into a situation in which you use bad fertilizer. Whenever I use a new nutrient formulation, I always recommend to people that they take a quick moment before using it the first time and notice what it smells like, what the consistency is like, and what the color is. This will be important in case you ever get into a situation in which you think perhaps your nutrient solution has gone bad. You'll be able to identify how the nutrient solution should have been from the start. So, those are some quick tips for applying fertilizers. There's definitely more that we can get into in a later video, but those are the basics of what you'll need to understand in order to use the nutrients, in order to actually get a beneficial result out of them and see a greater yield and greater quality of products. So now that we've gone over the EC and ppm, thanks so much for watching, and we hope you enjoyed this video. If you did, please make sure to share this with your friends, as well as provide us any feedback you have on the content we provided today. You'll also be able to find additional resources related to the content we discussed today available here. Thanks so much for watching, and we hope you enjoyed, and keep an eye out for additional grow videos coming out in the near future.